Hello everyone. Till the last session, so we have discussed about star connections and delta connections and power calculation in star connection and delta connection. So now we shall move on to the problems in the same topic. So the first problem says, so a three-phase delta connected balanced load consumes a power of, consumes a power of 60 kilowatts, right? So based on the given data, so I can write it as Pin is equal to 60 kilowatts. Okay, so now here the delta connection data is provided here. So a three-phase delta connected balanced load. Okay, so balanced load already I have discussed about. I have already told you about the difference between the balanced load and unbalanced load. So balanced load consumes a power of 60 kilowatts. Okay, so taking a current of 200 amperes. Taking a current of 200 amperes means that is the supply current, so IL, which is equal to 200 amperes. Okay, and lagging at line voltage. So remember here the line voltage value is provided. So line voltage is nothing but VL, which is equal to 400 volts, right? 400 volts, and of course the frequency is also given. So frequency is equal to 50 hertz, and so here we need to find out. So look at the equation, find the parameter of each phase if the load is connected in star. Okay, remember, so we need to find out the parameter of each phase when the load is connected in star. When the load is connected in star with the power consumed in star connection. Okay, with these given values, so next we can find out, because the power is given and we have IL, VL. So using these values we can find out the power factor or phi, which is, we know that P is equal to root 3 VL IL cos phi. Okay, so we can substitute it. Again it is P in, so substitute the value of P in, which is 60 kilowatts, that means into 10 power 3 is equal to, so root 3, and VL is 400 and IL is 200 and cos phi. So we can calculate the value of cos phi, and once we calculate the value of cos phi, so we can also find out the value of phi, which is cos inverse of. So now let us find the value of cos phi. So now the value of phi is 64.34 degree, so lagging. So why it is lagging? Because it is clearly given. So taking a current of 200 amperes lagging at line voltage, the phi which we have calculated, which is 64.30 degree. Okay, so 30 degree angle, and which is lagging. And once we find this value, it is phi. So now we need to have the values, like each phase values in delta connection first. So later we can find out the parameters in each phase, parameters of each phase in star connection. So in delta connection, and in delta connection we know that VL is equal to VPH. Okay, as we have already proved this equation, that is relationship between the line values and phase values. So in delta connection VL is equal to VPH or VPH. So what is VPH here? Because it is equal to VL, and VL value is given here, which is equal to 400 volts. And what is IL here, or what is IPH? IPH is equal to IL by root 3. The same equation we have derived in delta connection. IPH is equal to IL by root 3. So what is IL? IL is equal to 200 divided by root 3. So value is 115.47 amperes. So once we find the values of VPH and IPH, we can find out the value of ZPH. Okay, the load at each phase. So ZPH is equal to what? ZPH is equal to VPH divided by IPH. Now substitute the values of VPH and IPH here, that is VPH is equal to 400, so divided by 115.47. So we get ZPH as 3.464. Okay, so 3.464, and remember, so since we have calculated the value of phi here, so we need to express this ZPH in terms of this x or some value at an angle of okay 64.30. So now this is the value of ZPH. So remember, when we express the value of Z, okay, so we need to express in terms of this magnitude, okay, so that is x value, and at an angle of some y value, that is angle that we have obtained from this phi. Okay, so we have got this ZPH. So here we have obtained ZPH in polar form. So here how to convert polar to rectangular or rectangular to polar. So this we will be teaching in the offline session or in the further session. So, and once we convert this polar, so remember polar will be in the form of this some x at an angle of this y. Okay, this y is nothing but what? The phase which we have obtained from this point. So later if we convert this to rectangular, so this will be in the form of z is equal to x plus jy. Okay, so this is how we represent in so rectangular form. And once we convert this, so we get ZPH is equal to 1.5 plus 3.122. So what is x now? X is equal to 1.5, so plus j into y. So y is nothing but 3.122. So now it is in the form of, this equation is in the form of what? Z is equal to r plus j into xl. So remember the equation which we have obtained in rectangular form is z is equal to r plus j into xl. Now what are the values of r and xl? R value is nothing but, that means resistance value is 1.5 and xl value is 3.122. So by getting these two values, so we are going to calculate the parameters of each phase in star connection. Now by comparing these two expressions, so we can have the resistor value as 1.5 ohm, and what is XL value? XL is equal to 3.122. Okay, so can we calculate L from this equation? Of course, because you know that XL is equal to 2 pi f into L, where L is equal to XL divided by 2 pi f. Okay, so what is XL? That is 3.122. So divided by 2 pi into, and frequency value is also given in the problem, that is 50 Hertz. 50. Finally, L is equal to 9.93 millihenry. So remember, we have calculated the value of R and L. This is for, or this is per phase. So remember the values which we have calculated, that is for R and L, this is per phase. And since it is a balanced load, since the circuit, the connection is balanced load, okay, so we have 3 loads here, that is Z1, Z2, Z3. So all the loads are having the same values, R and L. So remember, load is nothing but what? Z. Okay, ZPH. This is per phase. So ZPH is equal to, so 1.5 plus j into 3.122. So we have just calculated the value of R and this L. And so later we will move on to the star connection. That means the question is find the parameters of each phase and when the load is star connected. Okay, and what will be the power consumed. So now we need to find out the parameters of each phase in star connection. That means when the load is connected in star. And before we find the parameters of each phase in star, so remember, so till now we have just calculated the parameters of each phase in delta. Okay, even though the values are provided, but we have calculated the parameters of each phase, isn't it? See here, look at this. So we have calculated ZPH. So this is irrespective of the star and delta connection, this load remains same. So in star connection, so we need to find out this VL. So what is VL here? VL is nothing but root 3 VPH, right? So root 3 VPH, or VPH is equal to, so VPH is equal to what? VL by root 3. So what is VL? VL is equal to, remember, the line and the line values always remain same. Line values, whether it could be line current or line voltage, it is same. So VL, which is 400 divided by root 3. So we can calculate the value of VPH. And what is IPH? IPH is equal to, so remember this is nothing but, so let us take the relationship here. So VPH divided by ZPH. See here directly we are not equating IPH is equal to IL. No, here we need to find out, because we need to find out IPH using this ZPH, using the ZPH which we have calculated from the previous part. So VPH is equal to 230.94. So 94 volts, and substitute here because we are talking about star connection. So we need to find out always VPH using this VL. Once it is done, then substitute VPH. So what is VPH? 230.9. So divided by, and ZPH. So what is ZPH here? So ZPH is equal to, so PH is equal to 3.464. So remember the value which we are substituting here, which we are substituting at this point should be in polar form. So polar form, so we have obtained 3.464, and simplify this expression. So after simplification, so we get IPH as, so 66.67 amperes. Okay, so we have obtained the value of VPH and IPH. And what is IL here? So IL is equal to, in delta connection we know that IL is equal to IPH. Okay, so IL is equal to IPH, where IPH is 66.67 amperes. Here we have calculated VPH, IPH, right? And later, so we need to find out the power consumed, and what will be the power consumed here. So P is equal to, we know that even in star connection, root 3 VL IL cos phi. So we can directly substitute VL. So what is VL, which we have got there? So of course it is 400 into IL is equal to 66.67 into, so what is cos phi? So already we have calculated cos phi, so which was 0.433. So simplify this equation. So P is equal to 20 kilowatts. So we get power consumed in star connection as 20 kilowatts, right? So remember in delta connection it was 60 kilowatts, right? So it was 60 kilowatts, and in star connection it is 20 kilowatts. So what you can understand from this? So the power in delta connection is 3 times the power in star connection. Remember the power in delta connection, which is equal to 3 times the power in star connection, isn't it? So if you just multiply this 20 with 3, so you will be getting power in delta as 60 kilowatts. Now look at the next problem. So the next problem is a balanced 3-phase star connected load draws power, okay, which draws a power from 440 volts supply, right? So now the 2 wattmeters connected indicate W1 is equal to, so this is the reading from the first wattmeter, that is 5 kilowatts, and the reading from the second wattmeter, that is 1.2 kilowatts. So now the question is calculate power factor, okay, and the line current in a circuit. So the first part is we need to find out the power. So how do we find the total power in a 3-phase circuit, whether it could be star or delta? So remember, so to find the power, and we know that the total power is equal to the summation of what? The wattmeter reading. So summation of W1 and W2, right? So always to find the total power, so we just consider the readings from 2 wattmeters. So the total power is equal to W1, which is equal to 5 kilo plus, and W2 is 1.2 kilo. So what do we get? Power is equal to 6.2 kilowatts, right? And the next part is power factor. So what is power factor? So we know that power factor can be represented as cos. So remember, power factor is equal to cos phi. And now we need to replace this phi. So what is phi? Because already we have done this derivation, that is power factor calculation using 2 wattmeters method. So here cos of what is phi? Phi is equal to tan inverse of what? So root 3 W1 minus W2 divided by W1 plus W2. So already we have done this derivation. So we can have this equation. Here by substituting the values of W1, W2, we can calculate the value of power factor, and so we will be getting 0.68856. So we will be getting power factor as 0.6856, which is lagging. And so the next part is we need to find out the line current. So what is line current? And to find the line current, so we should have the power equation which we have already derived, that is power is equal to root 3 VL IL cos phi. Okay, so what is IL? IL is equal to P divided by, so root 3 VL cos phi. Here substitute the value of P which we have already calculated here, and substitute the VL value which is provided in the problem, that is 440 volts, and substitute cos phi, that is power factor. So finally we will be getting the value of IL, so which is 11.886 amperes. Okay. So in the next problem, you can read out the problem. A balanced star connected load. Okay, a balanced star connected load. So remember, the connection is star connection. Load of 8 plus j. So this is 8 plus j 6. That means the load value is provided. If the load value is provided means now this will be in the form of R plus G into XL. So remember, now the given value which is in the form of R plus J into XL is connected to a three-phase. Circuit, of course. Here 3-phase and 230 volts supply. Okay, so we have 230 volts supply. That means, so remember the line supply which is equal to 230 volts. And so ZPH is given here. So ZPH is equal to 8 plus J into 6. Okay, J into 6 ohm, because the unit of impedance is also ohms. And here we need to find out what? Find the line current. Power factor, and power reactive volt amperes. Okay, so power reactive volt amperes and total volt amperes. So here in a star connection we need to find out the line current. And before we find out the line current, so first we need to have ZPH in the form of polar. So ZPH in the form of polar, so that means we get 10 at an angle of 36.86. Okay, so we get ZPH as 10 at an angle. So remember, whenever we convert from rectangular form to polar form, so we will be getting in this form, that means some x at an angle of y. Okay, and whenever we convert this polar to rectangular means, so it must be in this form, that means x plus j into y, right? So we have obtained ZPH as 10 at an angle of 36.86. So now our aim is to find the line current. So what is the line current? And before that, so let us have VPH. Okay, what is the relationship between VPH and VL in star connection? So here VPH is equal to VL divided by root 3, right? So why I am calculating VPH? Because before we find the value of line current, so we need to find out IPH, that is phase current. Okay, so before we find the line current, so we must calculate the phase current. To find the phase current, so we need to have the value of VPH. So VPH is equal to VL by root 3. So what is VL? VL is equal to 230 volts divided by root 3. Okay, and in the next case, so to find the value of IPH, so we know that IPH is equal to VPH divided by ZPH, right? So we can have this value over here, Okay, after simplifying this expression, we can have this here and divided by this ZPH. And in ZPH, so remember we are going to have only the magnitude, that is 10. Okay, we are not taking this 36.86, that is angle. So we are considering only the magnitude, and VPH is equal to 132.79. Okay, that is in terms of volts, and substitute here, that is 132.79. So we get the value of IPH, and once we get the value of IPH, so we can equate IL as IPH. Why we are equating? Because in the star connection IL is equal to IPH. IPH is equal to 13.27 amperes. So we need to calculate the value of power factor. So remember, there is one more equation to find the power factor. Okay, that is the second, this is the second part, and this is the first part. So to find the power factor, and of course we know that which is equal to cos phi. So cos phi is equal to R divided by Z. So already I have explained this equation in the earlier session. So cos phi can also be expressed as R divided by Z. So what is R? R is nothing but 8. Okay, so resistance which we have obtained from this equation, given equation, and Z is equal to 10. So power factor is equal to 8 by 10, which is equal to 0.8. Right. So after power factor, we need to have power reactive volt amperes. That means here we have two powers. One is active power, P is equal to root 3 VL IL cos phi. Right. So already we have obtained the values of VL, IL, and then we know the power factor. Substitute all the values to find the active power and the reactive power. So there is one more power, we call it as reactive power. So this we express in terms of root 3 VL IL sin phi. So only thing you need to have the value of phi. So substitute this phi here to find the reactive power. So in the last part, that is total volt amperes, okay, so which is equal to, so root 3 VL and then IL. So which is equal to what? Total volt amperes. So while calculating total volt amperes, so we need not to have cos phi and sin phi. So we can have only root 3 VL into IL. So in this way we can calculate the values of line current, power factor, power. Okay, so power means, so that means active power. So remember, the active power is always P is equal to root 3 VL IL cos phi, and the reactive power is equal to root 3 VL IL sin phi, and the total volt ampere which is equal to root 3 VL IL. Thank you.